So in this lecture, we'll discuss the relative merits of CSTRs versus PFRs in series. First, we'll consider a continuous stirred tank reactor. Now, we know the mole balance, in terms of conversion here, is V is equal to FA naught times X all over minus RA. Recall that we evaluate a CSTR by the exit conditions because a CSTR is considered a well-mixed reactor. Extrapolating from this, we can say that for CSTRs in series, our equation will be V is equal to FA naught multiplied by the exit conversions minus the inlet conversion, all over the rate of reaction at the exit. We'd like to be able to depict this graphically and find V. So a good way to do that is a Levenspiel plot, where we'll plot X versus FA naught over minus RA. Our reasoning for this is that the conversion multiplied by FA naught over minus RA is equal to the volume. In this first image here, you can see that the volume necessary to achieve a conversion of X1 will be X1 multiplied by FA naught divided by minus RA at X1. We could, however, decrease the total necessary volume by using two CSTRs in series. Two CSTRs in series, first V1 and then a volume V2, would have the same exit conversion as our original CSTR, but you can see that the volume would be much less. Now, for a plugged flow reactor, the situation is a little different. Using our conversion-based mole balance, we know that V is equal to FA naught multiplied by the integral from 0 to x of dx divided by minus RA. In series, using the same logic as before, we just now evaluate from the inlet conversion to the exit conversion. On a Levenspiel plot, this can be graphically represented as the area underneath the curve. You can see in this diagram here that the volume of a PFR, represented as the volume underneath the curve, would not be reduced by using PFR in series. Thus, for a PFR, there's no benefit to using them in series, whereas for a CSTR, there is a benefit. The point to take away from this lecture is that a Levenspiel plot can be used to graphically represent the volume in both a CSTR and a PFR. The PFR's volume is represented as the volume underneath the curve, and there's no benefit to using PFRs in series. CSTRs, on the other hand, can decrease the total volume needed to achieve the same conversion by putting them in series, because the volume of a CSTR is dependent on the exit conversion.